Hello friends, today we are discuss some problems on the NMR spectroscopy. Now look toward the first problem, that is molecular formula having a C12H10. Then UV spectra is also given here, 242 nanometer. IR is 1600 and 1480 per centimeter. NMR 7.4 delta M 22 millimeter. So friend, this is the given data related to first NMR problem which we have discussed in these videos. So let's start to solve it. I just write here first molecular formula which is shown in this page, C12H10. So first of all, we want to find out the site of unsaturation. And in our previous video, we have already looked the formula of site of unsaturation. Then site of unsaturation means number of carbon into 2 plus 2, it is alkane formula, minus number of hydrogen atom, that is a 10 divided by 2. Therefore 24 plus 2, that is a 26 minus 10 upon 2. Here is a 16 by 2 and site of unsaturation is 8. Isn't it? In this numerical we will be go detail step by step. Now second thing, that is the 242 nanometer, and this UV data reflect that there is a conjugation or conjugated system. Then IR data, that is 1600 1418 is clearly indicates that there is a carbon-carbon double bond. We show 1418 and 1600 which shows that there is the aromatic ring. Isn't it? There is aromatic ring. Then next NMR data is only one, that is the 7.4 delta 22 millimeter, that is the area covered by the proton atoms which we have discussed in the theory lectures of NMR spectroscopy. Now friends, 7.4 delta, this value is nothing but the aromatic protons, isn't it? And if aromatic proton and there is 8 site of unsaturation and aromatic ring is also present, the possibility is only one, that there may be two benzene rings. The question is arises, can two benzene rings join to each other? If two benzene rings join to each other, that is nothing but the naphthalene. But number of hydrogen atom cannot be 10. We will be get in case of the naphthalene. In that case, the number of hydrogen atom is only 8. So the two benzene ring is joined in this way with a single bond. And this possibility can prove the number of hydrogen atoms 10, the site of unsaturation is 8, this is a 3 and 3 6, one ring itself is one site of unsaturation and therefore it is a 8 site of unsaturation, and the same delta value of the proton, that is a 7.4. So friend, this molecular formula having this structure is this one on the given data. Now let's start to solve the second numerical or second problem which are based on the NMR. I hope it is visible to you. The molecular formula, that is C8H7N. So friend, as you know, in TYBSc you had already studied that one nitrogen group is replaced by one CH group. Therefore, the new molecular formula is C9H8. isn't it? Then when we find out the site of unsaturation, in short, 9 to the 18, 20, 20 minus 8 by 2, we will be get the 12 by 2, the 6th site of unsaturation. Now friends, look toward the UV data is also given here, 235 nanometer. This is also shows the aromatic ring or conjugations. And there is a somewhat the chromophoric group is also joined to the benzene ring. So friend, next data is also very important, that is IR 2220 means 2220. This indicate that there is the clear cut C triple bond N group. This frequency is very specific for the cyanide. Then 1620 for the aromatic ring and 1510 for the C double bond C and CH stretching, isn't it? Now look toward that, the NMR data. The first NMR data, that is a 2.4 delta singlet 15 millimeters. So friend, here the area under peak is very important to calculate the number of hydrogen atom. So the second data related to that, 7.2 doublet J for 8 Hertz 10 mm. You know the coupling constant is nothing but the distance between the two adjacent peak is known as the coupling constant, and coupling constant is mostly common for the number of ring system. For example, in benzene there is artho meta, and para coupling is already I told to you in that video, isn't it? Then the third one data is 7.5 delta doublet J is equal to 8 Hertz and 10 mm. So friend, look toward the number of protons. Here is a 7, and then as per that proton we have to find out the ratio related to this. The minimum ratio, if I have take here the 5, then therefore this is a 2 hydrogen atom, there is a 2 hydrogen atom, and this is the 3 hydrogen atom. Then count that 3, 5, 6, 7. Therefore it is the complete fulfill our condition, that is a 7 hydrogen atom, and therefore whatever the ratio, minimum ratio we have to consider, that is the 5 mm is equal to 1 proton, that is the correct one. Then we proceed for the next, the 2.4 delta 3 hydrogen atom can show singlet, therefore it is the methyl group attached to that another carbon atom which cannot containing any type of the hydrogen atom, therefore the methyl group shows the singlet. Then 7.2 and 7.5 is clearly indicate that there is the aromatic proton, but which aromatic proton? Of course the coupling constant it is 8 Hertz, and therefore that aromatic proton is of course the means ortho to each other, that is the aromatic proton, and this is clear by the coupling constant. Now friends, look toward that, one is a CH3 group, another one is the aromatic proton, and by the IR group we have already find out the cyanide group, that is a C triple bond N, and therefore I just attach C triple bond N group here and the CH3 group here, and we get the structure from the given molecular formula. You just count the number of carbon, that is the 8 carbon atom, number of hydrogen, that is the 7 hydrogen atom, coupling constant is also match, and IR data is also match, whatever the structure we have to find out here. So friend, this is the second NMR problem which we have solved. Now we proceed toward the third NMR problem. Look toward this. I hope it is visualized to you. Which one is the third? The molecular formula having a C8H7N. I just write here. We have proceed for this numerical, isn't it? C8 H7N. As per the above numerical, no, where the solid? Where the sol here? Now the second one is remains, that is the C7 H14O. So it is also very interesting. The UV data is given here 295. There is the conjugations, and conjugated there is the N to pi transition. Okay, non-bonded electron transition is found in these numericals. We are solve this one. Now IR data. There is a 1710 per centimeter, clearly indicates that there is the carbonyl group. Okay, now look friend, the NMR data. NMR data is 1.05 delta, doublet, J is equal to 6.5 hertz and 6 mm. Area is given for that. The second NMR data 2.7 delta, septate, very important information, J is equal to 6.5 hertz and 6 mm. Now friend, before going to solve this, we just find out first site of unsaturation. 14, 7 to the 14, 16 minus 14 by 2. There is a 2 by 2 is equal to 1 site of unsaturation, isn't it? There is the 1 site of unsaturation. Sorry for inconvenience. Now it is a 1 site of unsaturation. Now look toward the NMR data. This NMR data 6 mm can shows doublet, 6 mm can show septate. Actually this NMR cannot be matched with the given delta values. So I just consider this one septate. Septate means what? One proton shows septate is like this. Only this possibility is here, isn't it? And the second one proton can shows doublet. Actually instead of this, it may be 36. Therefore 6 proton can shows doublet, means this one and this one. Here may be the 36 millimeter. So friend, this is the one fragment, and coupling constant related to this proton to this hydrogen is of course 6.5 hertz. 6.5 hertz. Now only this much fragments we will be get from the following data. Then look toward this. There is how many carbon atoms? 7 carbon atoms, and here we got only the information regarding to the 3 carbon atom. So friends, it may be the symmetrical molecule. Symmetrical molecule. Now look and fulfill the data. That is the carbonyl group which can contain 1 site of unsaturation. Then this is the this hydrogen atom shows the septate. You know that n plus 1 rule, 6 plus 1, that is a septate. And this 3 hydrogen atom and this 3 hydrogen atom shows doublet. And this is the carbonyl group. Okay. Now friends, in this way we have to solve this example. Now we proceed for the next example. That is a C10H13Cl. C10H30Cl, 13Cl. I write here molecular formula C10H13Cl. So look toward first of all we will solve the site of unsaturation. As you know friend, one halogen atom is replaced by one hydrogen atom. Are you know that? Yeah. And therefore the number of hydrogen atom is 14. You have to consider. Then 22 minus 14 by 2 is equal to how much? Correct. There is a 8 by 2 and therefore 4 site of unsaturation. So the data for that next is, the NMR data is given directly here. 1.5 delta 6 hydrogen atom. Isn't it? Means 6 hydrogen atom can shows the singlet. This is for the singlet. Now 3 delta 2 hydrogen atom can show singlet. And 7.2 delta 5 hydrogen atom can singlet. Now friend, it's very important information that 7.2 delta and 5 hydrogen atom means it is a mono substituted aromatic ring. Mono substituted aromatic ring. And site of unsaturation 4 is satisfied in this ring. Therefore mono substituted. Now remaining group we should be find out. 6 hydrogen can shows singlet and 2 hydrogen also can shows the singlet. Then what is the possibility? And here is the mono substituted ring. Yeah, the possibility is like this. Then this is the 6. When you consider there is a 6 hydrogen atom, then of course there is the 2 methyl group. Okay, then 6, 7, 8 and this CH2. 6, 7, 8, 9 and of course this 10th carbon is nothing but this. Of course the 10th, this is the 6, 7, 8, 9, 10. The 10th carbon is this carbon atom and therefore the structure of the given molecule is maybe like this. And there is no another possibility is found for this, isn't it? Therefore this is the structure for the given molecular formula. Now you just find out, count the number of hydrogen atom. 5 and this 6, 11, 12, 13. One hydrogen atom. This 2 methyl group is too much deshielded as compared to this 3 methyl. This 2 proton is deshielded due to the chlorine atom attached to this one, and this 3 methyl group is not deshielded as compared to this 2 proton. Why? Because of the, because this methyl group is attached to the carbon compound. Now friends, in our next video we will be solve the another examples. Thank you very much.